All right, in example 1, part E, they tell us to substitute the expression that we got in part D into the function in order to write an expression for f of x sub k. So they tell us f of x sub k is equal to f of what x sub k is, a plus k times delta x. And so let me just rewrite that using our expression from part D. So that was f of, and we found a, that was our lower boundary of our interval, plus, and remember that k was multiplied by delta x, which was 1 over n, and so that gave us 1 plus k over n. So we're taking 1 plus k over n and we're doing composition of functions. We're substituting this into f. Now what was f? Well, remember that f of x was 2 times x, and so this then becomes 2 times 1 plus k over n. Now, building off of this, they tell us they want us to write an expression for the area of the kth rectangle. Well, to do that, I need to have the height of the rectangle, which is f of x sub k. That's where the rectangle goes up to the function. So it has the street address of x sub k on the x-axis for the right corner of our rectangle, and it goes all the way up to the function, and that f of x is the y value. So f of xk is the height of the rectangle, delta x is the width of the rectangle, and so we just found f of xk. That was 2 times 1 plus k over n, and we're going to multiply that by our delta x. And so remember that delta x was 1 over n. We did that in part C. And in part G, they want us to put all of this together. And so they want us to write the sigma notation for the area under the function using the limit definition. So let's do this. So this is going to be the definite integral from 1 to 2 of 2x dx, and that will be equal to the limit as n approaches infinity of the sum n equals 1 to n 2 times 1 plus k over n times 1 over n.